Today we're going to talk about factoring. And factoring is something that you've done before. You just haven't done it with polynomials, but you've done this with square roots and with numbers themselves. So for instance, like 18, you've broken it into its factors, and they call this the prime factorization. So really what you're doing with factoring is seeing what can be divided out of a number, or what can be divided out. So we can do the same thing with variables and expressions, essentially, so polynomials. So what we have to do is, and this is called factoring by the greatest common factor. So we're going to look at each term, and on this first example, I'm going to kind of show you the long way to do this, and then I'll show you the shortcut. But we're going to look at each term and figure out what we can divide out of each one. So if I look at 5x to the third, that's 5 times x. And then if I look at 10, I've got 10. I can split that into 2 times 5, and then x squared, x, and x. And then 30, I can split this into 3 times 10, or 3 times 2 times 5, and times x. And what we can look at here then is, what do all these things have in common? Well, they all have a 5 in common. We can see that. And then how many x's do they have in common, or the max amount of x's that they have in common, which would only be 1, because the last term there only has 1 x, which means we can only take 1 out of the other one. So our common factor here is 5x. And this is kind of like a backwards distributive property. This is what's going to come out. We're dividing that out of each term, and then what's left over is all the stuff that we didn't use. So for instance, here we did not use x times x, so that's x squared. And on this one, we did not use the 2 and the x, so that's plus 2x. On this one, we didn't use the 3 and the 2, so we'll times those. And since it was a minus, we get that. So this is our factored answer. And like I said, that's kind of the long way to do it, by drawing everything out. But you're going to get real good at this where you don't have to do that. So the shortcut would be is to just look at all your numbers, your coefficients, the 5, the 10, and the 30. What can you divide out of all those? It's 5. And then what are the what's the maximum amount of x's that you see? That you can take out of all of them, and that's going to have to be the smallest amount, which is x. I can only take out 1x because that last term only has 1. I can't take out more than it has. So let's kind of look at the next couple here with some other tricks here. So kind of doing a shortcut on this one. You have two options. You could pull out a negative coefficient, a negative factor, or you could pull out a positive factor. Neither of them are wrong. What I'm going to do is show you how to pull out a negative on this one. So if I look at my numbers, -6, -12, and 15, each of those can be divided by 3. I'm going to take out a -3. And then if we look at our variables, one of them has an x squared, the other one has an x, and the last number doesn't have an x at all. So I actually cannot pull out any variables here because of that last term. And now we just look at what we have left. Well, if I take this term, I divided it by -3. So now -6 divided by -3 is 2. And I didn't take out any variables, so x squared is still there. And then I take this divided by -3. -12 divided by -3 is positive 4. And we did not take out any x's. And then I take 15 divided by -3, I get -5. And so basically, if you take out a negative, it's going to turn on the inside of your parentheses all the signs to their opposites, because what has to happen, and you can always check your answer this way. So this is the factored version of this particular expression. If you were to redistribute everything, it should bring us right back to where we started. Okay, so this is the factored version of that answer. All right, and lastly, what do we do if we have multiple variables? Oh, and I probably should have mentioned on this last one, the other answer you could have had is if you just took out a regular 3, the only difference is your signs would stay the same as how we started out. So plus 5 here. So these are both acceptable answers for that one. Sorry. Okay. Okay. This one, same deal. Look at our numbers. So 2, -16, -8. I'm going to take out a 2 because they can both be divided by 2. Oops. We're going to take out some variables here too. Okay. Taking out a 2. And then we're going to look at our x's. This has an x squared, this has an x, but our last term doesn't have an x. So we can't take out any x's. So then we move on to our next variable. This has a y to the second, a y to the second, and a y to the second. They all have one, so I can take out y to the second. And then we just go with what's left over. We took out a 2, we took out a y squared, we did not take out an x squared. Okay, minus, and then we take that 16 divided by 2, which is 8, and we are left with an x in there as well. And then we also divide this by 2 to get 4, and we already took out the y squared, so this would be our factored answer. Basically just looking at what can we divide everything by, take that out, and factor our expression. So I like to think of factoring as the kind of the opposite of the distributive property. And again, you can always check your answer by redistributing and seeing if you get what you started with. We're going to use this for a bunch of different things in the near future, and these are just the beginning steps of factoring.